everyone, my name is Vinisha.
And this is Madan.
We are undergoing a post graduation program in data science. Today, we are going to show you how you can automate data visualization using Python.
Some of the important things that we need to know moving forward is what is data visualization, where do we use it, why do we use it, and the idea behind it will be explained in the form of code through Jupyter Notebook. We'll also be giving you some idea about the challenges we faced while doing this project, and we'll also show you how to create and use a package that contains the functions that create graphs for a specific data set.
Now, what is data visualization? It refers to graphical representation of information and data. It can be in the form of graphs, charts, and maps.
Where do we need it? To build statistical models and to build machine learning algorithms, we use data visualization to check for correlation and also to hold our audience's interest longer. And for every analyst, storytelling being a very important part, data visualization plays a major role.
Why do we need it? It is the best way to communicate the insights derived from data analysis. Looking at the graphs and charts, you can quickly absorb all the information. It helps in finding the outliers, finding the patterns and trends in data, and they are very easy to understand.
So here I'll be giving you the idea behind our project. So this is our first function that we created, the graph function version 1. We have defined the function, we have imported some libraries to take us through the entire process. We have read the data set and stored it in a variable called data. We are initiating a loop to separate the index and the column names. We are storing it in a string, empty string, under a variable b. We are also getting the data types of every column. So the reason behind this is to separate numerical and categorical data. So you can see that we are checking the length of each of the column with unique values. If the length is less than 15, we consider it to be categorical data, or if the data type of that particular column is object, we also consider it to be categorical data. We also use a function from Seaborn to create a bar plot, which is the SNS.factor plot part. And as arguments, we give the column name, the data set, and we also tweak the dimensions a bit so that we end up getting a bar plot. And we also give the x tick labels, which is the x-axis labels, which overlap generally. If we are able to rotate it by an angle of 45 degree, then they don't overlap. So that's why we have included this function called set x ticks labels rotation is equal to 45. So we have plotted the title of the bar plot, we have plotted the x label, we have plotted the y-axis label, we have saved the figure in a directory under a folder called new images, and we have also printed the plot. So that was for the categorical data. Moving forward, we have created an else condition for the numerical data, which gets plotted in the form of a histogram and a box plot. So here you can see we are plotting a histogram for that column, and we are plotting the title of the histogram, the X label for the histogram, the Y label for the histogram, and we save the figure. Similarly for a box plot. Now we are using the function on the dataset. You can see that we get a bar plot, and we also get other plots in the form of histogram box plots. That is the numerical data and the categorical data getting separated. So now Vinisha will be explaining about the second version and the third version of our function.
So here we came up with graph version 2, where we give access to user that whatever they column they want, they can have the graphs of those columns only. For that, the entire code remains the same, but we have added another argument called number of columns. We are passing this as a list of index of columns. So for that, we have given a condition so that if number of columns is none, that is, if user doesn't provide any information about the column, keep it as none, then print entire graphs of every column and of the data set. Else, else go down and We are now reading the index of the column and passing it to a variable called all columns we need. Now we are assigning a new data frame of required columns only. So here we are passing data, all columns we need, to a new data frame called the needed data frame. Again, the process remains the same, but this time we are generating graphs for needed data frames only. For loop continues, we are plotting the bar plots, and else condition, we are plotting histogram and box plot. Here you can see we have passed the argument like this. Graphs version 2 cars my data set and list of 1, 3 and 5 columns only. So the graphs of column 1, 3 and 5 are printed over here. Then we came up with graphs version 3. We thought we should give users to define their own directory. For so far they are getting saved in default directory. Now user can define their own directory as new path. There is a third argument called new path. For that, we are giving condition like if a new path is found in the existing directory, if not found in the existing directory, then create a new path, or else save the entire charts and graphs in the same folder. Now rest remains the same, like continues for if none columns, plots, and for required columns, these are the plots, and they will be saved in new path. You can see we have defined the new path over here. Here, every time we are saving the figure, we are changing the path with user provided path. We have called upon our function graph version 3 with cast data set, columns we need, and path provided. Now they are getting saved in graphs 1 with these columns. We'll show you how to create a package and call this function, call this library, and use functions. So for that, just download this Python notebook as .py. It will be getting downloaded here. Let's just go to my directory where I was working. It is in downloads. We can see it over here. It has been downloaded with the same timing. I'll change this to graphs 2. This is my package name now. I go to Python notebook. I open a new Jupyter notebook, and here we can directly call upon our package with the function import graphs 2. Sorry, graphs 2. This was my name. Now it will be getting imported here. So by the time it is getting imported, let me show you where version 1 graphs were getting imported. It was in C drive, downloads, new images. Let's go to new images folder. It's new images. I was trying this function previously, so let's just delete the entire set. Now this folder is empty. We can see this. This has been imported. Now graphs. We'll just call upon this library graphs 2. When we press the tab, we can see our functions over here. I'll show you first version 1 and then version 3, like this only. We'll call cars data here and we'll press run. By the time it is getting printed, let's do the coding for graphs 2 also, version 3 also. See, you can see now graphs are getting printed, and let's see if they're getting saved or not. So see, they are getting saved here. Now let's run function 3. Graphs, press tab, go to version 3, enter, call your dataset, give the columns name you want, and provide the path. Let's just say we want to create a folder over here only. Sorry. We'll quickly change the extension syntax. Now I will create a new folder with version 3. I'll run this code and see, you can see graphs are here and one folder is created here with the graphs, desired graph. So here we come to end. If you like this video, please do like, share and comment. Thank you so much.